You are told that everything around you is made of matter, solid matter, stable matter, tiny pieces forming bigger pieces. You trust this without thinking. The chair beneath you feels solid. The wall feels solid. Your own body feels undeniable, dense, real. So you imagine atoms as tiny versions of these objects, miniature grains of existence, little spheres, hard cores, definite edges. But this picture collapses the moment you look closely. An atom is not a small object. It is mostly nothing. If you could enlarge an atom until its nucleus was the size of a marble, the nearest electron would orbit hundreds of meters away. Between them, emptiness, not air, not invisible substance, just absence. The world feels continuous. Matter feels packed and dense. But at its foundation, reality is structured like a vast emptiness with rare disturbances. And yet, despite this emptiness, things feel solid. Why? You are told that everything around you is made of matter, solid matter, stable matter, tiny pieces forming bigger pieces. You trust this without thinking. The chair beneath you feels solid. The wall feels solid. Your own body feels undeniable, dense, real. So you imagine atoms as tiny versions of these objects, miniature grains of existence, little spheres, hard cores, definite edges. But this picture collapses the moment you look closely. An atom is not a small object. It is mostly nothing. If you could enlarge an atom until its nucleus was the size of a marble, the nearest electron would orbit hundreds of meters away. Between them, emptiness, not air, not invisible substance, just absence. The world feels continuous. Matter feels packed and dense, but at its foundation, reality is structured like a vast emptiness with rare disturbances. And yet, despite this emptiness, things feel solid. Why? Not because matter is full, but because forces resist your touch. When your hand presses a table, nothing actually hits anything in the ordinary sense. Electric fields repel electric fields. Patterns resist patterns. You never truly touch matter. You interact with structure. This is the first fracture in the story. Because if atoms are mostly empty space held together by invisible interactions, then solidity is not a property of substance. It is an effect, a behavior, a consequence of something deeper. The idea of a thing begins to slip, but the discomfort goes further. Even the tiny nucleus at the center, the supposed core of the atom, is not a solid object in the way you imagine. It is not a miniature rock. It is a dense region of interacting particles that themselves are not simple pieces of stuff. Already the idea of breaking an atom into parts becomes suspicious. What exactly are you breaking? You expect smaller objects hiding inside larger ones, like opening a box and finding smaller boxes, like cutting a stone into fragments. But atoms are not containers. They are not built from miniature building blocks stacked together. They are stable patterns, patterns of motion, patterns of interaction, patterns that only appear solid because your senses smooth over the emptiness beneath. And when you split an atom, you are not smashing a tiny object. You are disturbing a delicate arrangement that was never truly solid to begin with. The world you experience is made of apparent things. Physics quietly tells you those things are not what they seem. And if matter is not made of solid pieces, if the very foundation of reality lacks substance, then the idea of simply breaking an atom already rests on a misunderstanding. This is where intuition begins to fail. You assume that splitting something reveals its components. Break a rock, you get smaller rocks. Cut a fruit, you get pieces of fruit. Divide anything, and the parts remain things. This logic feels universal. It feels unavoidable. It is also wrong. When physicists split an atom, what emerges is not a set of smaller objects waiting inside like hidden machinery. What appears instead are entities that do not behave like independent pieces at all. They behave like events. Consider what you expect from a piece. A piece should exist on its own. It should have clear boundaries. It should remain itself, whether you observe it or not. Subatomic particles refuse to obey these rules. Take the particles inside the nucleus, protons and neutrons. You might imagine them as tiny balls packed together, but when you examine them closely, even they are not fundamental objects. They are made of quarks bound by interactions so strong that the quarks can never be isolated. You cannot simply remove a quark and hold it in your hand, even in principle. Try to separate one, and the energy of separation creates entirely new particles instead. The piece refuses to become independent. This is deeply unsettling because it means what you thought were building blocks are not blocks at all. They are temporary arrangements that only exist within certain conditions. Remove the conditions and the identity changes. The parts depend on the whole. This reverses ordinary logic. In everyday life, the whole depends on its parts. In the atomic world, the parts themselves rely on the system they belong to. Even electrons, often imagined as tiny orbiting objects, are not little spheres traveling along paths. They are better described as disturbances in a field, temporary excitations that cannot rely on the surrounding structure to exist at all. A ripple in water is not a separate object from the water. It is a behavior of the water. In a similar way, what you call a particle is more like a ripple in the fabric of reality than a miniature object moving through space. So when an atom is split, you are not releasing stored pieces. You are transforming one pattern into others. New particles appear. Old ones vanish. Identities shift depending on energy and interaction. Nothing behaves like permanent fragments of a broken whole. And this creates a strange tension in the idea of matter itself. Because if the smallest constituents of reality are not truly independent things, if they cannot exist alone, cannot be cleanly separated, cannot maintain stable identity, then what does it mean for anything to be made of them? The familiar image of reality as a collection of objects begins to dissolve. You expected pieces, you found relationships, and once the notion of independent parts disappears, the next assumption becomes unstable. The belief that these entities at least exist somewhere. Even if the pieces are strange, you still assume one thing. They must exist somewhere. A particle, however unusual, should at least have a position, a place, a definite location in space. This feels unavoidable. Existence itself seems to require it. But inside the atom, location dissolves. You imagine an electron orbiting the nucleus like a planet around a star, a tiny object following a path, always somewhere, even when unseen. This picture is comforting. This picture is wrong. An electron does not travel along a clear trajectory. It does not occupy a single definite position until an interaction forces one to appear. Instead, it exists as a spread of possibilities, a cloud of potential locations, not hidden positions, not unknown positions, no position at all, only probabilities. This is not a limitation of measurement. It is not a technological problem waiting to be solved. It is a property of reality itself. This realization was formalized by Werner Heisenberg. His uncertainty principle is often misunderstood as a statement about imperfect observation, but its meaning is far more disturbing. Nature does not assign precise position and motion simultaneously. The world itself refuses to choose. The more precisely you force an electron into a location, the less defined its motion becomes. The more you define its motion, the more its location dissolves into uncertainty. Reality withdraws from clarity the moment you demand it. So what is an electron before measurement? Not a tiny object waiting to be found, not a hidden dot in space. It is a distribution of possible events. When an atom is split, this strange existence becomes unavoidable. The particles that emerge do not simply travel along predictable paths like fragments of shattering glass. They appear in ways described only by probabilities, patterns of likelihood spreading through space. You cannot say exactly where they are. You can only say where they might be. This challenges something deeper than physics, because your entire intuition about reality assumes that objects occupy definite places, whether you observe them or not. The world, you assume, is fully formed behind the scenes. Quantum behavior suggests otherwise. Location itself becomes conditional, something that crystallizes only during interaction. Before that moment, reality remains suspended between possibilities. The atom you thought you could split into smaller pieces was never made of localized objects in the first place. Its components are not things in positions. They are potential events waiting to occur. And when position becomes uncertain, another assumption quietly collapses. The belief that what emerges from splitting an atom is a physical substance stored inside. Because if the constituents are not solid objects in definite places, then what exactly is being released? You are told that splitting an atom releases energy. The phrase sounds simple, familiar, almost mechanical, energy stored inside, energy waiting to escape, energy released like pressure from a container. You imagine the atom as a tiny reservoir, a compressed store of power locked within matter. Break the container and the energy spills out. This picture feels obvious. This picture is wrong. Energy is not a substance hidden inside objects. It is not a fluid. It is not a material that can be stored like water in a tank. When an atom is split, nothing physical pours out of it. No hidden fuel escapes. No invisible liquid is released. What actually happens is far stranger. Mass itself changes identity. This realization emerged from the work of Albert Einstein, whose famous relation between mass and energy is often reduced to a slogan, but its meaning is deeply unsettling. Mass is not separate from energy. Mass is energy. What you think of as solid matter is simply one form that energy can take, a stable configuration, a particular way energy arranges itself. So when an atom is split, a portion of what you called mass does not disappear or get released from storage. It transforms into different forms of energy, motion, radiation, heat. The identity of the system changes. Imagine a tightly wound spring. The spring contains potential energy because of its configuration, but the energy is not a separate substance hiding inside the metal. It is the structure itself, the arrangement, the tension, the relationship between parts. Atomic nuclei are similar, but far more extreme. Their mass reflects an intricate balance of forces and interactions. When that arrangement changes, the total structure shifts, and what you perceive as extra mass reappears as energy in other forms. Nothing was waiting inside. The change itself creates the difference. This challenges one of the most persistent intuitions about reality, that matter and energy are separate categories. Solid things here, abstract energy there. Physics quietly removes this boundary. Matter is frozen energy. Energy is liberated matter. Both are different expressions of the same underlying reality. And this transformation is not gentle. Inside the nucleus, forces operate with an intensity beyond everyday experience. Slight changes in arrangement produce enormous shifts in energy. Splitting the atom reveals how unstable the identity of matter truly is. The solid world begins to look less permanent. A piece of matter is no longer a self-contained object. It is a temporary configuration of energy, capable of becoming something entirely different under the right conditions. The atom you imagined as a stable building block becomes a fragile balance, a pattern that can rearrange itself into entirely new forms of existence. And if matter can lose its identity so completely, if even mass is not a fixed essence, then another assumption begins to collapse. You expect that whatever emerges from these transformations at least retains individuality, that particles remain distinct entities, each with its own persistent identity. But at the deepest level, even identity itself begins to fade. You assume that even the smallest parts of reality must possess identity. A thing should be itself. One particle should be distinguishable from another. Objects, however small, should carry individuality. This belief feels fundamental. Without identity, what would it even mean for something to exist? But in the atomic world, identity dissolves. Imagine two identical billiard balls placed on a table. You can label them, track their paths, follow each one as a separate object through time. Even if they look the same, they remain distinguishable by their history. Subatomic particles refuse this distinction. Two electrons are not merely similar. They are completely indistinguishable, not practically indistinguishable, not difficult to tell apart, fundamentally indistinguishable. There is no hidden label, no internal tag, no property that allows you, even in principle, to say which electron is which. If two electrons exchange places, nothing in the universe records that exchange. The situation is physically identical. Nature does not assign them individuality. This is not a limitation of knowledge. It is a statement about reality itself. The implications are profound, because individuality is one of the basic features of objects in everyday experience. Your phone is your phone because it occupies a specific place and carries a unique history. Its identity persists through time, but at the fundamental level, the building blocks of matter possess no personal identity to preserve. They are interchangeable in the deepest possible sense. This strange behavior was explored through the quantum framework developed by physicists like Paul Dirac, where the equations themselves demand that identical particles have no separate existence as individuals. The mathematics does not allow them to be distinguished because nature does not. A particle is not a tiny object with a personal history. It is an instance of a type, an occurrence of a pattern. Like identical ripples on a pond, you cannot point to one ripple and claim it has a separate identity from another. There is only the movement of the water forming temporary shapes. When an atom is split, the particles that emerge do not carry individual stories. They are not fragments of a broken object preserving their origin. They are manifestations of underlying processes, appearances of certain patterns allowed by the laws of physics. This erases another intuitive foundation of reality. You expect the world to be built from individual things, distinct units, persistent entities forming larger structures. But the atomic world suggests something different. What exists are not individuals, but repeatable behaviors, not unique objects, but recurring events. Identity, one of the most basic features of your everyday experience, becomes an illusion created by scale and complexity. And when identity disappears, the very idea of reality being made from objects begins to fail completely. If there are no solid pieces, no definite positions, no stored substance, no individual entities, then what remains? What is reality made of at all? You began with a simple assumption. Reality is made of things. Objects exist first. Interactions come later. The world is a collection of pieces that then influence one another. This assumption feels unavoidable. Your entire experience is built on it. You see separate objects. You move among them. You imagine the universe as a vast inventory of things. But splitting an atom quietly destroys this picture, because once solidity vanishes, once location dissolves, once substance transforms, and once identity disappears, the idea of independent objects becomes difficult to defend. Something else must take their place. Modern physics suggests a disturbing alternative. Reality is not made of things. Reality is made of relationships. At the deepest level we know, what you call particles are not little objects moving through empty space. They are excitations of underlying fields, continuous structures that exist everywhere. An electron is not a tiny bead traveling through the universe. It is a localized vibration of an electron field that fills all of space. The same is true for every fundamental particle. This changes the order of existence. The field is primary. The particle is secondary. The behavior comes first. The object is just the appearance of that behavior. Imagine a stretched fabric. When the fabric vibrates at certain points, you see temporary peaks and dips. You might label those disturbances as separate things, but they are not independent from the fabric. They are features of a continuous structure. In a similar way, the universe appears to be a network of interacting fields whose patterns give rise to what you experience as matter. What you call a particle is an event within a system, a temporary pattern in an ongoing process. And when an atom is split, you are not breaking objects apart. You are reshaping relationships between fields. You are forcing the underlying structure of reality into new patterns. This explains something that once seemed mysterious: why particles can appear and disappear, why their identities depend on interaction, why their properties emerge only under certain conditions. Because they were never independent objects to begin with. They are expressions of deeper connections. Even empty space is no longer truly empty. It contains fluctuating fields, restless activity, constant potential for events to emerge. What appears as nothingness is a sea of relationships waiting to manifest. The classical picture imagined a universe built from tiny building blocks arranged in space. The modern picture suggests something far less intuitive: a universe where structure exists before objects, where interactions define existence, where what you perceive as things are temporary stabilizations of deeper processes. You are not living in a world of objects. You are living inside a web of relationships that only appears as objects at human scale. And this realization carries a quiet but unsettling consequence. If reality is not made of things, if objects are merely convenient appearances emerging from deeper structure, then the everyday world of chairs, mountains, and bodies is not fundamental. It is a surface phenomenon, a useful illusion. And once this becomes clear, splitting an atom stops being a technical achievement. It becomes something far more disturbing. It reveals that the world of solid objects was never truly there. You began with a simple belief. The universe is made of objects, stable things, solid pieces of reality. Splitting an atom seemed like a way of examining those pieces, breaking matter into smaller components to understand what the world is made of. But step by step, that picture dissolved. First, matter lost its solidity. Then pieces stopped being independent. Location became uncertain. Energy replaced substance. Identity vanished. Objects became relationships. And now a disturbing possibility remains. What if there were never things at all? Not at the deepest level. The world you experience feels populated by objects, chairs, stones, bodies, planets. You see boundaries, you see separation, you see individuality. Your mind organizes reality into discrete units because that is what allows you to survive, to act, to navigate. But physics suggests this world of objects is not fundamental. It is an emergent appearance, a stable pattern arising from deeper processes too complex and too strange to resemble everyday experience. What you call a thing may simply be a region where relationships temporarily stabilize, where underlying fields and interactions settle into a persistent pattern that your senses interpret as an object. A chair is not ultimately a thing. It is a process that persists. Your body is not a fixed entity. It is a continuous transformation of energy and interaction. Even the atom itself, once imagined as the ultimate building block, becomes just another temporary structure in a deeper network of relationships. The universe begins to look less like a collection of objects and more like an ongoing event, a continuous unfolding, a structure that never pauses long enough to become a thing in the ordinary sense. And this realization does not merely change physics, it changes perspective. Because if reality is not built from objects, then separation becomes ambiguous. The boundary between one thing and another becomes a matter of description rather than fundamental truth. Distinctions blur. The world becomes less like a machine assembled from parts and more like a single evolving process. You are not standing in a universe of things. You are part of a pattern within a vast dynamic structure. This is what makes the act of splitting an atom so disturbing. It does not simply reveal smaller components of matter. It reveals that the idea of components itself may be a convenient fiction. It exposes the instability of the categories your mind relies on: object, substance, identity, location. The deeper reality resists all of them. And yet this is not a failure of understanding. It is an invitation to humility, because the universe does not promise to match human intuition. The structures that generate existence may be stranger than any picture the mind can comfortably hold. What physics uncovers is not a world that becomes more familiar with knowledge, but one that becomes more mysterious the deeper you look. Even the language of splitting begins to feel inadequate. Nothing truly breaks apart. Patterns transform. Relationships reorganize. The universe reshapes itself. And behind all appearances, behind matter, energy, particles, and space, something persists that is not easily described as a thing at all. A structure, a process, a reality that exists without needing to resemble anything your intuition expects. You started by imagining the atom as a tiny object you could break. You end with a universe where objects themselves may not truly exist, and the most unsettling possibility remains quietly in the background. The world feels solid, not because it is made of things, but because your mind needs it to be.